Good afternoon. Welcome back to the classroom. Welcome back to the kitchen for your Science Day 3 lesson. Today we're going to talk about energy, right? Everything that requires movement requires energy. Your bodies require energy. This marker requires energy. Now, it's not the energy that we think of, right? Like there's light right now in this kitchen because of light bulbs. And those light bulbs require, of course, energy. But it's not the same energy. We have electrical energy, we have hydro energy, which of course is energy that's generated by water. We have wind energy, which of course is generated by airflow, and of course we have the energy of our universe. Now, what we're going to address in this lesson are two types of energy. Okay, there's two types of energy. We have potential energy. Now, potential energy is energy of something that's at rest. And look up that word, potential, right? We all have potential. You have the potential to be lots of things when you grow up, depending on your work ethic, your education, how far you're willing to go, how passionate you are about things, right? So we have potential. This marker right now has potential energy. It's at rest, okay? It has the potential to go that way, to go this way, to go forward. Okay, the potential to be pulled down by the mass of Earth, potential to be tossed up in the air and then not caught by me. All right, there is potential. The energy of things at rest is known as potential energy. So if you see something sitting still, it has energy, right? Just because something isn't moving doesn't mean it doesn't have energy. In fact, things have energy all the time. It's called the law of conservation of energy, and of course conservation of matter. Matter cannot be created, nor can it be destroyed. Everything that exists, it's already here, right? Same thing with energy. Something can have potential energy, and then of course, if it's in motion, it gets our second kind of energy, and that energy is kinetic. Kinetic energy is the energy of something in motion. So you take a car. When a car is sitting in the driveway, it has potential energy. When you start the car and you put it in reverse or you put it into drive and the car begins to move, it goes from having potential energy to kinetic energy. Okay? And that's the difference between those two. Potential energy is something that's at rest. It has the potential to do a lot of things. Kinetic energy is the energy of something in motion. So you, sitting there in your chair right now, you have potential energy. You have the potential to do a lot of things. You have energy. When you stand up and line up to go to the restroom or to walk to the pencil sharpener or even so much as to go to the bus or the car line in the afternoon, you are going from potential energy, the energy of being at rest, to kinetic energy, the energy of motion. If I have a baseball, when I'm holding the baseball has potential energy, right? When I throw the ball and I put it into motion, it now has kinetic energy. If something were sitting at the top of a ramp, okay, let's say you got a ramp and something's getting ready to roll down it, right? At the top of the ramp, it has potential energy because it's sitting still. As it's rolling, it has kinetic energy, right? And then it comes to the bottom and friction and gravity slow it to a stop. Now it's not moving, but guess what? It still has energy, potential energy. We see this in a device called Newton's cradle. Now, I have one of these at school. I look forward to getting back and seeing you guys, and we'll talk about how it works. But there are metal balls that hang down. Now, while they're hanging completely still at rest, they each have potential energy, right? They have potential energy. Now, if I pull a ball back, we would call this Newton's third law. We would call this action, right? And if I let it go, it will swing back to where it was, its original position. Action, reaction. Now, the cool thing there is, while they're standing still, they have potential. Once we put this into motion, it now has kinetic energy. When this ball strikes this one, it's going to actually send its energy into this one, right? And so it's going to go from potential to kinetic, and now we're going to have action-reaction. This is going to transfer energy through, and this is going to transfer energy through. And when this ball gets here, since it has no one to give its energy to, it's going to go into motion. In other words, it's going to become kinetic. It's going to become kinetic. And the cool thing is, that will go out, that's in action, and then what's going to happen? That's right. The ball will then swing back. That's a reaction. And it will take its kinetic energy and it'll send it back through. And then this actually goes both ways. Now the balls in the very middle, they look like they move only a tad bit. But a lot more is happening there. Because it's not that they don't have the freedom of movement. It's that they are transferring this energy. Yeah. Now one thing to keep in mind. This will not happen forever and ever and ever and ever. Just as any of you all that have seen the Newton's cradle and have worked with it know that after 5, 10, 15 seconds, they begin to slow down and eventually the cradle goes into potential energy again. It goes into rest. And that's because of two factors. We have loss of energy. And where does that loss of energy come from? Where it comes through two parts. Every time the balls strike each other, there's friction. Okay? And that friction, of course, is slowing that down. Also, every time this ball tries to fly out, gravity trying to pull it back to the larger mass. So this may come out here the first time, and the second time a little lower, and then the third time a little lower, and the fourth time a little lower, and the fifth and sixth time till it doesn't swing at all. Once again, gravity and friction, they hate all forms of motion. So as soon as you have this, even though you have a potential energy that's transferred into kinetic energy and we have movement, gravity, friction, they're trying to slow down. And don't forget, you have friction in two places. You have friction where the balls are hitting each other, but you also have air friction. You also have that air resistance. When this ball swings out here, it's hitting millions of air molecules, and that's causing friction too, and it's slowing it down. So we have two types of energy. We have potential energy when things are at rest, and we have kinetic energy when things are in motion. Laying still on the couch, you have the potential to do a lot of things. You could lay there all day. You could get up and go play. You could set up and watch setting up instead of laying down. You have the potential. You're at rest. You have a lot of things you could do with your energy. Who knows? Kinetic energy, you're in motion. You've made a decision and you're on the move, right? When the football is in my hands and I'm looking down the field, I have potential energy. When I throw the ball and I put it in motion into a path, it's got kinetic now. Now it has motion and it's going. And it will keep going that way. After all, it's an object in motion. It will stay going in motion unless acted upon by an equal or opposite force. Do you know Newton's 3 laws by now? Law number 1, inertia. An object at rest will stay at rest. An object in motion will stay in motion. These things will stay true unless they're acted upon by equal or opposite forces. Newton's second law, force. Force equals mass times acceleration. How large something is multiplied by how fast it goes equals the amount of force, the amount of energy it generates, right? And then Newton's third law. For every action, there's an equal and opposite reaction. Two types of energy in this world. Potential energy when things are at rest, and kinetic energy when things are in motion. Excellent? Cool. Now let's move on to one more topic we're going to talk about today, and that is finding the median of a data set. Let me get a little bit of spray here. We've been working with mean, median, mode, and range. Now, mode and range, by now, you should have down really easy. After all, mode is when something happens a lot, when a number in a data set repeats. And remember, you may have two numbers that repeat the same number of times. You may have 3 numbers that repeat the same number of times. This, of course, is known as having more than one mode. However, remember, if no number repeats at all, then you can have no mode. Range, of course, was even easier. You just take the largest data, the largest value, I should say, and you subtract the smallest value. And that's all you have to do for range. So now let's talk about median. When you think of median, you should literally be thinking of the middle, because that's all, not the mid-E, doofball teacher. You should be thinking about the middle, because that's all the median is. In fact, if you've ever been driving down the road before and there was a piece of raised concrete in the center of the road and your parents said, oh, that's the median. You can't cross the median. That's what the median is. It's the middle, right? So take a look at this data set. 1, 2, 3, 4, 5. Okay? To get the median, all you have to do is find the middle number. So check it out. I do this by making sure that the numbers are in order. I usually go from the smallest to the largest. Okay? And you'll see why this is important in a second. And then we cross out end to end until we get to the middle, right? So we cross out the smallest, we cross out the largest. We cross out the smallest, we cross out the largest. What we're left with is the middle. In this data set, the median is 3. Okay? So check this out. This is why this is important. So let's take a data set of numbers, and we're going to mix them up a little bit. So let's do an 11, 42, 36, 25, 9, and 55. Perfect. Okay. So first off, what happens when I'm given this data set of numbers that are all in order? When you want to find median, the first thing you need to do is put the numbers in order. Okay? Put them in order. So my smallest one is 9. And then I've got 11. I'm going to cross these out so that I don't do one of those. Then I've got 25. Then I've got 36. Then I've got 42. And then I've got 55. Okay, now, check it out. I have them in order. And once again, I've gone from the smallest to the largest. And this will always help you. When you are doing median, take those data sets and put them in order from the smallest to the largest. And now, just like I did, all I have to do is cross out small, large, small, large, small, large until I get to the middle. So, smallest, largest, smallest, largest. Ooh. So what happens is sometimes you have an even number in a data set. And when you do, you take these two numbers and you add them. And then you divide them by 2. Okay? And this gives you your median. So we start with 25 plus 36. 6 plus 5 is 11. Carry the 1. 2 plus 3 is 5. Plus 1 is 6. That gives me 61. Now I'm going to divide 61 by 2. And that's going to give me 30.5. So the median of this data set is 30.5. Now, once again, if you have an even number of data sets, if you have an even number of values, you're going to take the 2 that are in the middle, you're going to add them together, and then you're going to divide that by 2. Okay? So, let's do another example. And once again, sometimes everything's going to work out wonderful for you. Anytime you have a data set of odd numbers, right? An odd number of values in the data set, things are going to be good because it's going to work out easy. Let me show you what I mean. Okay? 10, 20, 30, 40, 50, 60, 70. Now these are already in order. And look how many values we have. 1, 2, 3, 4, 5, 6, 7. That's an odd number. This is going to be great. It's going to work out real easy for me. Small, large, small, large, small, large, only one number left. Okay? let's do it with mixed up, okay? Let's do 84, 36, 72, 12, 6th grade, Glasgow, Kentucky. That's one city, and there's 2 high schools in it. Okay. Now look, 1, 2, 3, 4, 5, 6. Yeah, we got 1, 2, 3, 4, 5, 6, 7. Now, what you do is we have these numbers. They're all jumbled up. So the first thing I'm going to do is I'm going to put my data set in order, and I'm doing that from smallest to largest. So 1, 2, 6, 12, 36, 72, 84. Okay, see that? All right, so now we're ready. Now we have them from smallest to largest, and we just cross out that way. Small, large, small, large, small, large, until we get to the middle. So small, large, small, large, small, large. The median is 12, okay? When you have an odd number of values, 3 numbers, 5 numbers, 7 numbers, 9 numbers, it's easy because it's always going to be that middle number. Small, large, you'll always come here. The only time it gets tricky, my friends, is if you have an even number of values in the set. Okay? So let's do one more of those so that you have an example to look at as you practice. Okay? Now once again, we're working with median, and median is the middle. Okay? So if you have an even number of data in the set, then you're going to have to add and divide by 2. So check it out. 55, 17, 99, 21, 36. That's 1, 2, 3, 4, 5. And let's get one more number. 60. 62. Why not? There we go. Okay. So now I have 6 numbers in the data set. What's my first step? That's right. I'm going to put them in order from smallest to largest. So here we go. 17, 21, 36, 55, 62, 99. Okay, now that I have them in order, okay, now, oops, well, that's wild. It's still wet down there, that's why, okay. 99, oh, I gotta dry it some more. Live action! Okay, sorry. All right, that should dry it up. Okay, so now, and now my marker's wet, so... All right, let's try this. Maybe we'll have better luck. Yeah, there we go. 99. Okay. So now I have my numbers, okay? Now we're going to do what we have been doing. We're going to cross out small, large, small, large, small, large until we get to the 2 that are in the middle. Small, large, and here are our 2 in the middle. Now remember, we're going to add, and then we're going to divide by 2. Okay? So 36 and 55. Okay? So here's 55 plus 36. 6 plus 5 is 11. Carry my 1. 1 plus 5 is 6. 6 plus 3 is 9. So I've got 91 divided by 2, and that's going to come out to 45.5. So the median of this data set is 45.5. Okay? There's another little video here for you to watch. Once again, he goes through median very easy. And then you have a quiz. Don't rush. Take your time. I've given you some of each type of problem. Okay? There'll be some where there are 5 numbers and just small, large, and here's this nice one right in the middle. There are also going to be some where you have 2 in the middle. So once again, what do? You add those together and then you divide it by 2. Kind of like when we do the area of a triangle. You put those first 2 numbers, you multiply those, then you split it in half, divide by 2. Same thing here. You add the 2 values in the middle and then you divide by 2. I love you guys. I miss you guys. I can't wait to see you next week. Science Day 1, Science Day 2, Science Day 3, and then Science Day 4. All 4 days, all 4 lessons and quizzes, and the ReadWorks articles and activities, and your practice test. All of those things are due by Friday. Please, don't waste time in class. Use your time wisely. If you need to get into contact with me, email me, Class Dojo, Google Classroom, holler at me anytime. I'm more than happy to help. I can't wait to see you soon. Bye.